Hi, in the last session, we talked about the cloud platform in the ORAN system. In this session, we will talk about Network Function Virtualization. NFV is being developed by ETSI, which is another big community in the RAN systems. They are working towards virtualizing the different network functions on any hardware. Network Function Virtualization (NFV) virtually decouples the infrastructure from the different network functions like ODU, OCU, and RIC from the ORAN perspective. Let's understand it in a simple way. First, we need some general purpose hardware which includes computation unit for processing that have some storage and that should have the network adapters. In simple, you can consider your computer or laptop which has all these three items assembled. You can deploy the virtualization layer on these hardware through the hypervisor. You can simply understand it like you installed one operating system upon your hardware. Now inside that, you created another virtual machine which reserves some of the resources from your system. Same way with the hypervisor, you reserved some resources from your hardware and created some individual virtual machines which actually sharing the same hardware. So for example, here you created 3 virtual machines, so you can deploy ODU or OCU or RIC on these virtual layers. Like at some point of time, network needs more OCU, then simply system will demand for the additional resource for the OCU and it will be provided from the pool of resources. Then a virtual system will be created and the software function of OCU will be deployed on that virtual machine and it will be ready with the additional OCU unit on the same hardware. So no need to add any additional hardware for the OCU now with the cloud and virtualization system. Same way, we can get any other function whatever is needed in the network. Simply virtualize the resources from the pool of hardware, create a virtual machine and deploy that software function which is needed with the more capacity. This function can be ODU, OCU, RIC or even any individual third-party function. These all the hardware resources and virtual resources are being managed by the NFVM, which is called Network Function Virtualization Manager. The job of this NVM is to manage everything for that NFVI, Network Function Virtualization Infrastructure. Same way, the software instances for the VNF, Virtualized Network Function, are also being managed by NFVM. These management system decides when these VNF systems or NFV systems should on or when these should off, and all these management happens through the orchestration. Means orchestrator is responsible for managing all these different software functions and hardware resources. For example, if any new service or feature is planned to deploy in the network, then from reserving the hardware to managing the software will be managed by the orchestrator. Orchestrator is also responsible for scale up or scale down any function from the network services. Even orchestrator has the power to terminate any service from the system which is not required by the network. So that respective hardware resources can be free and can available for other needy functions. Let's see how it works quickly. So you can see here is the generalized hardware with computation system like CPU and GPU. There is network adapter and some storage devices like NVMe, SSD or HDD or hard disk. Hypervisor is a technique which can reserve some of the hardware resources for some specific virtual system so that one hardware can be shared between multiple functions virtually. This infrastructure is managed by Virtualized Infrastructure Manager (VIM), which will manage these resources to distribute between multiple virtual machines and different functions. These functions can be anything like in open network, these virtual machines can be used for virtual ODU, virtual OCU, virtual RIC. Also, there are some core network entities which can be integrated in those virtual machines. Like for 5G network systems, we can have virtual AMF, access and mobility function, virtual UPF, user plane function, virtual PCF, policy and control function, etc. These all functions can be enabled or disabled or can be scaled up or scaled down by the VNF, Virtualization Network Functions Managers. ORAN network systems also has the NFVO, Network Function Virtualization Orchestrator, which manages the VNF and different network functions in the ORAN. Orchestrator can enable or disable any services from the system as well based on their needs. For example, You need to create the 5G network at some location or wanted to enable some of the 5G services in the network, then it can be managed by the orchestrator. Orchestrator can enable or disable any nodes in the network like AMF, UPF, OCU, RIC, etc. Let's go through the process quickly, how it happens. Suppose OSS, Operations Support System, requests some network function to add in the network. Then this request will go to the orchestrator first, which will validate the request and will check the feasibility for that and will pass the requirement to the VNF, which will check the available resources in the pool and confirms back if the resources are available for the new function. Then orchestrator will give the command to VIM, Virtualization Infrastructure Managers, to allocate the necessary resources for the new function and create a virtual machine or virtual network function. Once the orchestrator gets the confirmation that the virtual machine or the network function is ready, orchestrator will give the command to VNF manager to enable that new function in the network. And that's it. The new network function is ready for action in the network. This was just a high-level overview to understand the cycle, that how it works. In the next session, we will talk about the software-defined networks and their deployment in the OpenRAN system. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for the regular updates. If this video is informative, then please like this video, comment on video and don't forget to share. Thank you for watching.